Hello student, we are here to discuss about the compiler and its phases. As you all know, the compiler is a translator or an intermediator which convert high level programming language into the machine language. But the compiler not directly convert your high level program language into the machine language. Instead, it will convert it into an intermediate code called as a assembly code. Then the assembler is used to translate this assembly code into a machine code. Once the program is read by your compiler, it will be passed through a different phases of the compiler. Usually the compiler has 6 main phases like lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer and final code generator. Each phase will perform a different task in the compilation process. Let us see all these phases in detail. The first phase of the compiler is called a lexical analysis. The main role of the lexical analyzer in the compilation process is to generate the token. The next question arises, how it generate the token. First, it will scan your source program left to right single character at a time, group them into the lexemes matching with the patterns and create the token for that. The diagram shows the interaction between the lexical analysis and the parser. So parser it come in the next phase of the compiler. So whenever the parser require the token, it will send a signal to the lexical analysis saying that get next token. Once this signal is received by the lexical analysis, it will read a source program for the lexemes which are matching with the patterns, and once it match with the patterns, the token is generated for that and the same will be sent to the parser for further analysis. It will make an entry of that token in the symbol table also for further reference. So here we are coming across with the new terms like token, pattern and lexeme. Let us define this. What is a lexeme here? Lexeme is nothing but the sequence of character written in the source program. So in a high level language program, you are going to write a sequence of characters and these characters are called as a lexemes here. Each lexeme has a description and this description is called as a pattern. And once the pattern is identified, then the particular token is generated for that pattern. So what is a token here? Token is a pair consisting of token name and optional attribute value. The lexical analyzer, it will not only generate the token, it will perform other important tasks also, like stripping out of the comment line from your source program, removing the white spaces from your source program, plus it will keep track of a new line character seen, which help for the compiler to display the error message along with the line number. Let us see the role of the compiler by taking the example. So I think all of you know how to write the pattern. So pattern is written by using the regular expression and some meta characters. So this we already discussed in the lab. If I ask you to write a pattern to recognize the token ID, then you must know the rule to define the ID. So what is the rule to define the ID? That ID should start with the character, then it is followed by any number of characters or numbers. So this is a pattern I had written to recognize the ID. So what I had written here in the first part, that it should have a character. So character come in the range of A to Z. It may be a capital letter or it may be a small case letter. Then this character may be followed by the number of characters or a digit. So star indicate here whatever is immediately preceded by this star can occur 0 or any number of time. If anything is matched with this pattern, then the token is created and the name of the token is ID here. Same thing you can write like this also. So letter is nothing but a character between this range. It may be a capital letter or it may be a small case letter. Then this is the pattern to recognize the ID. It is same as this. Then take an example of your source code. So one line I had taken, that is a declaration of the variable int a comma b semicolon. So let's check out how the lexical analyzer read this line. Lexical analyzer start reading this line left to right single character at a time. So first it read I. So after reading this I lexeme, it will come to know that this lexeme is matching to a pattern returned to recognize the ID. Then it will read the N. Again this is matching with the same pattern. T, yes, it is matching the same pattern. Then it will read the next character, that is space. Space is not a part of this pattern. So it will group these lexemes which are matching with the same pattern and it will create the token for that. So I is a one lexeme, N is a one lexeme here, T is a one lexeme. It will be grouped together because all these are matching with the same pattern. Then the token is created for that. So it will create a token for this lexeme as a ID. Once the space come, it will be deleted by, the space will be stripped out by a lexical analyzer. So after stripping this space, the next character is A. A is again matching with the same pattern. So it will create this A as a second identifier. Comma, it is not a part of this pattern. So the separate pattern is written for the separators, comma and semicolon. So how many lexemes it will create? 1, 2, 3, 4, 5 lexemes. Among that, 3 lexemes are matching with the pattern returned to recognize the token ID. Let's take another example, that printf bracket double quotation ID double quotation complete comma score close bracket and semicolon. So here how many lexemes are created? Printf is a one lexeme, open bracket is a second lexeme. Whatever is written in a double quotation, that is considered as a constant and single lexeme is created for this. So this is a third lexeme. Fourth one is for comma, fifth for score, sixth for close bracket and seventh for semicolon. Among these 7 lexeme, 2 lexemes, those are printf and score, are matching to a pattern returned to recognize the ID. So this is recognized as the ID and this is recognized as a ID. So as we know, printf is not an identifier, it is a keyword. Here int is not an identifier, it is a keyword. But this is not known by the lexical analyzer. The rectification or the segregation of the keywords and the identifiers is done by the further phases of the compiler. The intermediate step in the construction of the lexical analyzer is to convert this pattern into a flowchart called as a transition diagram. So transition diagram, as you all know, it is made up of states and the transitions. So the pattern returned to recognize the identifier is letter. Letter is followed by any number of letters or a digit. So how to draw the transition diagram for this? So I start with the start state, say it as a state 1. So if letter come, move to a next state. So here star is there, star indicate 0 or any number of times. So this star is shown by a loop here. So loop indicate this thing will occur 0 or n number of times. Other than this letter or digit, if anything come, move to a third state and this is a final state here. After moving to this state, return a token along with the attribute value. So what is the token here for this int a comma b? So int is a token which is matching with the pattern written for the identifier. A For A, the token is ID. For B, the token is ID. So I had written here token name ID, 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 and these are the attributes for that. So same thing is explained for other patterns also, like number and white spaces. Just go through with these diagrams and the patterns. If you have any doubt, call me. Thank you.